Is it getting where it needs to be?
Dwight and engineers from Ansell Incorporated added a dye to the chemical, vastly improving their ability to aim. His refinements never surprised firefighter Jerry Kraft.
A lot of people wonder how Dwight Williams does the things. It's not magic. There's no trickery to it. He's a good team player, and he knows how to put together a team. As long as you have the right team there, you can pretty much accomplish a lot of things.
Yeah.
All right, did good, guys. Did good. Was y'all a little warm?
Yeah. Didn't feel a thing.
It didn't feel anything, did you?
The advancement is just one of the latest inventions of dozens attributed to the Williams family. Like foams to smother flames, powerful, sophisticated monitor nozzles, and other high-tech devices. All would become weapons in an industry long desperate for solutions. After the start of the oil industry in America in the late 1800s, came the advent of large, difficult petroleum fires. Water proved of little use alone. Flammable liquid fires burned so hot that most of the water turned to steam. Fire brigades often stood helpless watching oil fields go up in flames. The industry would have more luck attacking the flames by cutting off the oxygen supply. Experimenting with thick and costly foam compounds, they tried to smother the fire. But getting the heavy foam to the flame created new problems, until a young engineer came on the scene, a man instrumental in developing the delivery systems that would ultimately save lives and the environment. This was Les Williams, Dwight's father, a man baptized to fire at an early age. As a sailor aboard an aircraft carrier in 1945, 20-year-old Les Williams would witness one of the unique horrors of the war in the South Pacific, a kamikaze attack. The explosion and fire would kill 25 of his fellow sailors and wound 100 more. That night, Les was transformed from sailor to firefighter, suffering third-degree burns. Those wounds would heal, but in the experience, Les would find his life's passion, one that would change firefighting forever.
He was really the man that started this part of the industry. He was the Red Adair of the flammable liquid firefighting. He taught that to my brother. And when my brother goes to a fire now, he does the same thing.
My dad was an inventor. He was the kind of person that could look at what I needed and I could tell him what I needed. He'd have a drawing by the time we got home on a napkin.
They would go to a fire and they would figure out that, the nozzles we have didn't have the reach we need. It didn't have the volume. He invented the technology and made it work to make it safer. And as Dwight today will tell anyone, the safest protection from a fire is distance. And that's what his technology allows you to do, is it enables us today to be able to control these monsters.
After an early career working for refineries and oil companies, Les joined his son's team, a partnership that lasted until his death in 1993. In that time, they would make storage tanks a Williams specialty. Along America's Gulf Coast, storage tanks dot the landscape by the thousands, filled with crude oil and some of the world's most flammable, most dangerous liquids. In the past, when they caught fire, they were nearly impossible to put out. The Williams family would risk their lives figuring out how to better the odds. When the entire surface of one of these tanks is ablaze, firefighters face an inferno that will continually reignite no matter how much water is applied. The trick is to keep extinguished areas from reigniting. The Williams strategy: attack with continuous volumes of foam at an angle that creates a growing, smothering blanket.
The purpose of foam is basically just to build a barrier between the fuel surface and the atmosphere above it. It's putting a lid on top of the flammable liquid. And the way that the foam works, when it comes out of the nozzle, it entrains a little bit of air and allows it to float on top of the surface.
As the area or footprint of foam slowly grows, the area of fire shrinks until snuffed out. But tank fires come in other varieties. A notorious one finds opportunity in the floating roof. It prevents space where explosive vapors can build, but has a vulnerable spot, the rubber seal.
The seals that are maintained around the edges that wipe up and down the outer shell of the tank, they sometimes get compromised and the vapors are allowed to escape. Many of the seal fires that we see are started by bad weather, by lightning, by static electricity, but primarily lightning strikes.
When a seal catches fire, it becomes a nightmare. Fed like a wick from below, it will only succumb to concentrated foam, methodically applied.
In the old days, we'd get on there, we'd walk inside, down the ladder, on top of the floating roof that was floating on gasoline or crude oil, and we'd put the fire out with dry chemical extinguisher. My wife saw that happen on television in the very early days. I come home, she was telling me, "You're not going to believe there was two fools on top of a floating roof tank." And I never told her it was me. And when you get off, sometimes your shoes look like melted duck's feet. You realize you don't have to walk on something that could sink instantly, or pieces of it blow apart. You realize, we need to minimize the risk here.
We knew that we needed something up there that could be secured on the tank.
It was time to head for the shop. Today, Doug Daspit, also Dwight's son-in-law, oversees a team of dozens who build the equipment the Williams firefighters depend on.
I get a purchase order in from Betty, John, Kathy, someone in that nature from the front office. At that point, it's a piece of paper. Okay, my job is to make it become that.
The Williams manufacturing team produces equipment ordered by refineries around the world.
We've got an excellent support team, from our engineering staff to our machinists, to our fabricators, craftsmen, assemblers. The guys are putting their mark on, the best equipment manufactured.
Based on a prototype, Doug Daspit would create overnight a device that would be named for him, the Daspit tool. It would be put to the test on July 24, 2000. Williams responds to another seal fire on a 100-foot, almost 30-meter in diameter tank in Sealy, Texas. Clear from the firefighters' video, walking on the floating roof was out of the question.
The rubber seal that goes around the circumference of the lid or the roof, the floating roof, has burned away and is now exposed the crude oil in that area, and that's where it's catching the air, that's where it's burning. A seal fire left alone will burn a long, long time. The biggest motivator to put it out is environment. We don't want any smoke in the air. This particular town on that fire had been evacuated. It had now been burning some 11 hours. Their biggest question for us is, when can you put this fire out?
70 rungs up, Chauncey headed for the platform of the crude tank containing 80,000 barrels of hot oil. Flames jumped 20 feet above the seal.
We actually rigged up on it, got foam flowing, and they ran about 10 minutes while we continued rigging the Daspit tool. And then as you see us bring it into the tank, from that point on, if you count, the fire is out in less than 2 minutes, and we never left the platform.
Thanks to the Daspit tool, an important advance name for one son-in-law protects the life of the other.
The Daspit tool. A versatile piece of equipment, can be used all over the place, but how do I feel about it? That's my daddy's name, okay? There it is. That's how I feel about it. Okay.
Williams had proved it could put out a seal fire from a safer distance, but the contest had only begun. Soon, they will be asked to take on a tank many times larger than the Sealy tank, an ultimate test for the skill of any industrial firefighter. June 7, 2001, 1 p.m. A brutal tropical storm batters America's Gulf Coast. While those in Texas and Louisiana fight flooding, the fierce weather brings other worries. Days of rain have broken the seals on a dozen tanks, sinking the protective roofs, exposing volatile vapors to the environment. It's a script for disaster refinery fire chiefs like J.R. Chittister of Orion know too well.
You can have bad weather come in. You can have the possibility of a sunken roof. You could have one of your lightning strikes for a seal fire, or you could get your worst case scenario, which is a full involved tank fire.
Lightning strikes at 1:30 p.m. The horizon explodes 10 miles west of New Orleans, Louisiana. A gigantic tank fire rages at the Orion Norco refinery. Now, with the full attention of the media, this was a disaster like no other. At 270 feet, over 80 meters in diameter, containing about 300,000 barrels of fuel, Louisiana was witnessing the largest tank fire the world has ever seen.
My problem was I had a fire in my refinery, and my bosses wanted me to make this problem go away.
For the industry, this is a nightmare come true. The Orion fire chief knows early his crew needs help. Minutes after the eruption, the phone rings at the Williams Southeast Texas office. Randy Williams takes the call.
When the client first gets on the phone with me, you always ask, what is the emergency? If it's a tank fire, are there any process units involved? Are there any other tanks in jeopardy? What is the product? What is the size of the tank? What is the depth of the fuel? What's the closest water supply? What equipment do you have available? What foam do you have available? So there's a lot of questions that go into it.
Before the day is out, Dwight will face a demon he has spent his career preparing for, a fully involved jumbo tank fire.
When the information came in on the Orion fire and the diameter of the tank was confirmed to be a 270, knowing that everyone in the fire industry all had already proclaimed that this tank fire could not be extinguished. Could not be. There's always a concern.
The oil company doesn't want to hear that, I believe this is going to be very hard and dangerous. I mean, that's why they called. That's what they had. So you do the job. I felt like I should leave immediately and go help the fire chief manage the risk there.
2 p.m. at Williams headquarters. Randy assesses the monster that awaits the crew and some of what they'll need to slay it.
I can tell about how much hose it's going to take, whether it's going to be 5-inch hose, if we're going to need the other big equipment, just by the types of fires.
Challenged by flooded highways and closed airports, Randy must calculate how to move men and equipment almost 300 miles to the Orion refinery in Louisiana. Knowing the status of every piece of their multi-million-dollar inventory falls on the shoulders of Randy's 24-year-old son, Jason.
If the equipment doesn't work, we cannot put the fire out. The equipment has to work. Our pumps have to work. Our guns have to work. If it doesn't work, it's my fault. I'm the fall guy. Everything has to be ready to go day to day.
But effective extinguishment can come with a hefty price tag. John Morris, firefighter and 18-year employee, knows the bottom line.
When we are called for an emergency situation, for example, a storage tank fire at a refinery, this is going to cost money. The foam concentrate. This is a special concentrate that is made for us by Ansell. The cost on that for a 265-gallon tote is a little over $7,000. And as I said, we have to move this equipment. That cost. We also have our firefighters And really, what they have to sell is themselves and their knowledge. That cost.
We've had oil companies, when we present them with a bill, tell the fire chief, go buy the boys dinner on the oil company. This is fair.
If it seems like the fees are very high,